G'day everyone, today we're going to learn about arithmetic sequences. In this video, I'm going to take you through what defines an arithmetic sequence, as well as the formula for the nth term of an arithmetic sequence. We're also going to look through a few examples and also solve them. So we've got a few key dot points here around what defines an arithmetic sequence, or an AP, as it also might be defined. AP just stands for arithmetic progression. So an arithmetic sequence, I'll just condense all these definitions. This I think is the most important thing here, and it's just saying that an arithmetic sequence is defined by a sequence having a common difference. So if I have this sequence 1, 3, 5, 7, 9, and so on, that is an arithmetic sequence, or an AP, because the difference between each term is 2. So we say D equals 2. And how we get that is we take one term, let's say 3, and we subtract that from the term previous to it. So the D is equal to 3 minus 1, which is equal to 2. Alternatively, we can also work out that it's equal to 9 minus 7. So you just take one term, which we define as the nth term, and we subtract that from the n minus 1th term. And that's how we sort of come up with this, which is how we define an arithmetic sequence. So if there are ever questions that ask us to prove that this is an arithmetic sequence, we would just take 4 different terms and show that the difference between those terms is common. Now, if we consider the first term to be A and this common difference to be D, we can write out every arithmetic sequence as follows. So A, I'm going to say is the first term, and then D is the common difference. So if I go down a little bit, what I get is the first term is A, the next term is going to be A plus D, the next term is going to be A plus D plus another D, and it's going to keep going like this. So if we sort of collect the like terms, and so on. So if we take it back to this sequence here, A was 1 and D was 2. So we had 1, and then we had 1 plus 2, which was 3. And then we had 1 plus 2 times 2, which was 5. And then we had 1 plus 3 times 2, which was 7. And then we can keep going. So that means if we want to find the definition for the nth term, Tn, we realize that we always have this A, and it's plussing something multiplied by D. And what it is it's the n minus 1 times D. So I'll just put a times in there. And that's how we define whatever the nth term is going to be, because we can see that, if we look at this line here, this is T1, this is T2, this is T3. So n minus 1 means when we're looking at the third term, the n minus 1 is going to be equal to 2. So if we see here, we can see that the third term, it's A plus 2D. And that's how we define that there. So this is obviously the equation for the nth term in a very nice and neat formula. And this is what we'll be using to solve arithmetic sequence questions. So let's get into those questions. The first example we have here says find a formula for the nth term of the sequence 26, 35, 44, 53. So we know, remember, that the nth term is A plus n minus 1 D. They want us to find the formula for the nth term, which means n we don't need to solve. That is just something that we keep. But we do need to solve for A and D. So A we know is the first term, which is 26. and d is the common difference between two terms. So let's take the second term, 35, and subtract it from the first term, 26, and we see that we get 9. And now that we have this, we can therefore say that the nth term is 26 plus n minus 1 times d, times 9. So if we wanted to write it a bit neater, we could say 26 plus 9 n minus 1. Now, we can go a little bit further and we can expand like terms. Sorry, we can expand the brackets and then collect like terms. And what we end up getting is this. So we get Tn is equal to 17 plus 9n. And that's our answer. Now part B says how many terms are there in the sequence 26, 35, 44, 53, all the way to 917. So they want us to find however many terms there are in the sequence, and they give us the last term within the sequence, which they say is 917. So if we say Tn is equal to 917, and we need to find whatever n is, like it says, they're basically saying, what is this term? What number throughout the sequence is this term? So if we sub it into the equation here, it becomes a very easy formula to solve. So we get 917 equals 17 plus 9n. We subtract 17 on both sides. We get 900 equals 9n. Divide by 9, and we get n equals 100. So therefore, it's the 100th term. So we'll say that this is T100. That's essentially what this question is asking. Next example, part A, says show that the sequence 200, 193, 186 is an AP. So how do we show that it's an AP? Well, remember how we defined an AP, or an arithmetic sequence. And its definition was that it had a common difference. So if we take T2 minus T1, the difference between two terms, two successive terms, that is 193 minus 200, which is -7. Now this isn't enough to prove that it's an AP because we've just subtracted two terms. What we need to show is that the difference between two different sets of terms is common, or two different sets of successive terms. So they only give us T1, T2, and T3, and we've already used the difference between T1 and T2. So now let's look at the difference between T2 and T3. So T3 minus T2 is equal to 186 minus 193, which is equal to minus 7. And now that we've shown this, we can now conclude that the sequence is an arithmetic progression. It's an AP. So we'll say something like, therefore, since there is a common difference of -7, the sequence is an AP. So that's part A. Now part B says find a formula for the nth term. So we know Tn is equal to A plus n minus 1d. So that means we know our A is 200, that's the first term, plus n minus 1 times -7. Or we can say 200 minus 7 outside of n minus 1. Now if we want to expand, we can. And then so we get that Tn equals 207 minus 7n. Part C then says find the first negative term. So what is a negative number? A negative number is a number that is less than 0. So it's saying what is the n for which Tn is less than 0, for which it's negative. And so to solve this, we just say that 207 minus 7n is less than 0, and we solve for this equation. So if we add 7n to both sides, we get 207 is less than 7n. And if we divide both sides by 7, we get that 29.57 is less than n, or n is greater than 29.57. So our answer becomes 30. So the 30th term is the first term that's negative, because that's the first term when n is greater than 29.57. It's the first whole number, I should say. So we can't have non-integer numbers as terms. Like if I say that the half term, like if I said what's the half term of the sequence, it doesn't really make any sense, because you can only have the first term, the second term, the third term. No half term exists. And so we look at the first whole number that's greater than the inequality that we've worked out. And that gets us the 30th term. The next example says the third term of an AP is 16 and the 12th term is 79. Find the 41st term. So there's a few things going on here. So let's just write down the information that we know. We know the third term is 16, so we can say T3 is equal to 16. And we know the 12th term is 79, so T12 is equal to 79. Now we should know and remember that the nth term is given by this equation. So let's substitute the values that we know into this equation. So let's work with T3 equals 16. So we know that the third term is 16. So 16 equals A plus 3 minus 1D. So we get 16 equals A plus 2D. And then using the 12th term equals 79, we can say that 79 is equal to A plus 12 minus 1D, or that 79 equals A plus 11D. And what we can see here is that we have simultaneous equations. And it's just up to us to solve these. And so once we figure out A and D, we can then answer the question, which is find the 41st term. So what I'm going to do is I'm just going to make A the subject of this equation, call this equation 1, call this equation 2. Now, if I sub 1 into 2, because we know that A is 16 minus 2D, we can say 79 is equal to, so instead of A, I'm going to say it's 16 minus 2D, and then we still have this 11D, so plus 11D, and then we can just solve this. So 79 minus 16 is 63 equals 9D, and D equals 7. So that means we can then figure out A, so therefore A is equal to 16 minus 2 times 7, and that's just subbing it into this equation. So 16 minus 14, which is equal to 2. So now that we know A and D, we now know the formula for the nth term is 2 plus n minus 1 D, which is times 7. Or it's equal to 2 plus 7 n minus 1, or it's equal to 2 plus 7n minus 7, or it's equal to 7n minus 5. Now when we come to the actual question, which says find the 41st term, therefore T41, the 41st term, is equal to 7 times 41 minus 5. And that is equal to 282. And that's it. That's how we would work out this question. Next example says find the value of x if 3x12 form an AP. Now again, this is coming back to the definition of an AP, which is that there is a common difference. 3 is our first term, x is our second term, 12 is our third term. So that means D is T2 minus T1, and D is also T3 minus T2. So essentially we need to figure out the value of x for which these equations are equal to each other. So we can say that D is equal to x minus 3, which is T2 minus T1, But D is also supposed to be 12 minus X, which is coming from this formula here. So that means we can just equate them. So we can say X minus 3 equals 12 minus X, and we just solve. So we say 2X is equal to 15, and that means X is equal to 15 on 2, or 7.5. Now the last question we look at here is more of an application sort of question and giving a sort of real scenario. So the Roxanne Cinema has a concession for groups. It charges $24 for the first ticket and then $16 for each additional ticket. How much would 20 tickets cost? So before we get into the actual question of how much 20 tickets cost, let's realize that this is an arithmetic progression or an arithmetic sequence, an AP. And we see that they charge 24 for the first ticket and 16 for the next ticket. So if we looking at the total cost of tickets, they can be represented as each term. So the total cost of one ticket, T1, would be 24. And the total cost of the second ticket would be 24 plus 16. And then the third ticket, the total cost of like 3 tickets would be 24 plus 16 plus another 16. And it would sort of continue in this pattern. So what we can realize is that A is equal to 24 and D is equal to 16. So therefore, Tn is equal to 24 plus 16 outside of n minus 1. Now, how much would 20 tickets cost? So that means T20 is equal to 24 plus 16 outside of 20 minus 1, which is equal to 24 plus 16 times 19. And so if I just plug this all into my calculator, we get $328. And that's our answer for part A. Part B is a bit of a weird one. And it says find a formula for the cost of n tickets. So we've kind of done that already here. But what we're going to do is we're going to simplify that. So Tn equals 24 plus 16 outside of n minus 1, which is equal to 24 plus 16n minus 16. So that means we get Tn is equal to 8 plus 16n. And that's our formula for the cost of n tickets. Part C then says how many people are in a group whose tickets cost $600. So that's essentially saying when the total cost is $600, how many people were in the group. So that's just saying when Tn equals 600, what is n? Because that'll give us the number of people. So we'll get 600 is just equal to 18 plus 16n. If we subtract 8 on both sides, we get 592 equals 16n. And then 592 divided by 16 to solve the equation. And we get n is equal to 37 people. And that's our answer there. And that's all the questions that I'm going to go through. I hope that wasn't too difficult. I hope it makes sense. And that's just an overview of arithmetic sequences or APs, how we define them, and the formula for the nth term.